Hello everybody. In this video, we shall see the IoT and the functional blocks of IoT. IoT, which means Internet of Things, system comprises of number of functional blocks that provide the system the capabilities for identification, sensing, actuation, communication, and then management. IoT is a system. It's not a single device. It's a complicated system. What does it contain? The system contains certain devices for identification, certain devices which are used for sensing, then actuation. All these things should be communicated over the internet. And there is a software which is associated with that particular sensors, devices, to do some meaningful actions managed by the user. So basically, we have all these things put together comprises of IoT system containing the device for identification, then the devices for sensing, actuation, communication, and then management. So here, the device block includes all the IoT devices and sensors. The requirement of the devices here is to sense it, actuate it, monitor it, and control it. So all these things include the device. If I take an example, remote control based door locking system. Basically, it is a door locking system which is connected with an IoT enabled device. Basically, the need of the device is to get the signal from the user end by means of some manageable software and then perform the actuation. What do you mean by actuation? Actuation is to listen to what command the managing software is giving. Suppose remotely, if I press a button in my mobile to open the door lock, the actuation command gives the door locking system to open the lock. It opens just like a manual opening. Suppose if I say you lock the door, so automatically the system, the actuation system is going to lock the door. So here the device block includes all these things put together. So it's a device block. Device is not a single device, it's a device block which contains the sensors for sensing. Basically, it's very important. Based on the sensor data, basically, sensor data is a raw data. All our activities involved. For example, if I take the camera, CCTV camera, the camera has a sensor, and when it is sensing the moving objects, automatically it sends a control signals to the DVR for recording it. If it doesn't find anything moving, the DVR will not record. So DVR will record only those positions where the sensor is sensing the movement. So see, sensors are very important. They are the physical devices which are used to sense the real objects, which is then actuated, monitored, and controlled. Here the control is record that particular clips of the video wherein you find movement through the sensors. So like this, I can give n number of devices. For example, we have Alexa. It's a device. Normally we configure it and we keep the device somewhere in our showcase or somewhere near to the TV. And we say, Alexa, switch on the TV. See, we have sensors in Alexa. It's a device. So the device will take our audio signals and then it has a lot of audio processing NLP softwares which will identify what do we really mean. And then based on our command, it's going to switch on the TV or switch off the TV, or maybe it is going to do advanced activities as the program says, as the management software says. So all these things I can give examples for devices. Okay, so these devices collect the data from the environment. The purpose of the device is to collect the data from the environment. These devices are used to collect the data from environment or perform some actions at the environment. Ultimately, see, the action should be performed at the end. As I mentioned, switch on the TV or lock the door or open the door, or I may give an example of switch on the drip irrigation system and switch off the drip irrigation system based on the humidity available, based on the water vapors available and around the farming land. See, ultimately, our activity completes when we take some inputs from the environment and when we do some activities to the environment. So, for which devices are very important. Now, next functional block is the communication block. So here the communication block manages the transfer of data between IoT devices with the other IoT devices. We have already discussed, we have already seen. Communication could be from one IoT device to another IoT device. As we give example, like the motor is one device, the pump is one device which is used for irrigation. So pump will be switched on only when the sensor says that yes, there is a water needed to this particular agricultural land. So that sensor's data is communicated to the pump, and pump will be switched on when there is a need of water. At the same time, if the sensor finds that no, there is no need of the water, the agricultural land is completely having enough water, so the sensor will send a signal or a data through the communication line to the pump to switch off the pump. Here, the communication is done between the sensor, the humidity sensor, as well as the pump, device to device communication. Or communication may even extend to the application programs wherein a human being uses a mobile phone and he opens a application program. For example, you have a CCTV camera surrounding your house and an application program is in your mobile phone. So you can use that mobile phone and the data you can collect it from the individual CCTV camera. So the data will go from your house, the camera, through your DVR, through your internet line, and it is communicated to your mobile phone, maybe anywhere, you may be anywhere, and then you can process the data and you can get a meaningful result out of it. So basically, the two important functional blocks include the device and communication. Now, the services. What are the services that are possible from the IoT system? Number one, device monitoring. As we know, CCTV camera we have. What can we do through CCTV camera? We can monitor, we can record, we can see, but we cannot call the police when an intruder is coming to your house and the CCTV camera is there. CCTV camera is capturing your video, but CCTV camera cannot send a signal to the nearby police station stating that an intruder has come. So that you have to do. So you can monitor the device activity. Then device control. As we know, device control, pump is switched on or off by collecting the data from the irrigation sensor. So device control, by using a mobile application, I can lock my car, I can switch on the various lights of my car, I can see the health of my car. I can do some activities related to the car, and I can control my devices. I can switch on the TV using Alexa. I can shut down the, I can close the door, I can close the lock, I can open the lock. These are all device controls. So IoT system can be used for monitoring also, as well as IoT systems are used for device control also. Then data publishing. So we have various IoT systems wherein they publish the data, like today's weather report, tomorrow's possible weather condition. So it collects the data and it just publishes what is the carbon monoxide content in the air, so polluted air, what is the pollution rate. So the various environmental data could be published by using IoT systems. So even it could be used for device discovery also. So these services help manage device operations and data flow. So these are all the various services what we can expect from the IoT. So basically, there are different services. One is, as I told, management. So here you can configure the device, you can maintain the device, you can monitor the device, you can manage the resources, resource management. So all these activities of the IoT system come under management. So the purpose of the management of IoT include the smooth operation of the IoT infrastructure. So configuration of the device, how do we configure? According to our requirement. Maintain. We need to maintain the device, whether it is working according to our configuration or not. How do we maintain? Once in a week we may maintain. Once in 15 days we may maintain. Or once in a month we may maintain. So device maintenance is also a part of the management activity. Then monitoring. So we need to monitor the system and we need to keep the backup of the system. So in CCTV system, the DVR, depending upon the size of the hard disk of your DVR, it keeps the backup of the video of all the cameras, maybe for once in 15 days. So then automatically the oldest data gets vanished and it is overwritten by the new data. So these are all the configurations what we do to manage the activities of the IoT. So basically, the purpose of the IoT system here could be getting a smooth operation of the IoT infrastructure. Now, coming to security. Also, security is very important. It should not allow the intruder to come and change the activities. Intruder to come and delete some activities. So it provides authentication. You can touch the system. You can do the management only if you are an authenticated user. It provides the authentication username and password so that it helps in authorization. Then it helps in integrity of message integrity. Message integrity means it takes a lot of security in storing the data or even commuting the data also. Intruder may not take the data in between in the network. So content integrity, data security. See, all these are the various security aspects which are very much important, which protects the security, protects the IoT system against unauthorized access and unauthorized attacks. See, if the security is not available with any of the IoT system, then we are monitoring our IoT devices from a remote area. For example, if a car is getting stolen, the application software written on the mobile starts giving me the information. Car is, the door lock is open, the car is moving in this place, car is moving at this particular speed. So it gives the dynamic data, and the data should come only to me only. Nobody in between should take that data. If it takes that data, I will not be able to get the details of my car. So IoT system needs to be highly secured to ensure the protection of the data against unauthorized access and against the attacks. So security plays a very important role. Now coming to applications. Here, applications provide the user interface for integrating with the IoT system. Basically, users are connected to the activities of IoT system through application software. Probably those who buy Ether, they have an application software which manages the entire IoT system of the Ether vehicle. They anyone who buys who purchases a Maruti Nexa cars like Baleno or Froms or any higher end cars. Every higher end car has got a application software wherein user is controlling, user is monitoring, user is analyzing the activities using an application software. So it's a wonderful concept. I would give my own experience. So I have a Baleno car wherein I have an application software called Maruti Suzuki Connect. I can control my car using that particular app. I can monitor the status of the system. See, I can see where is the car, what is the condition of the car. So the day my car, the spark plug, there was an issue with the spark plug. So normally the dashboard or display gives us a message stating that please look into there is a problem in the engine. But my application software in the mobile also started showing me an alarm stating that you please look into your car because there is something wrong with the engine system. So monitoring is also that. Then analyze, view or analyze the processed data. It's a wonderful application which we can look into. So whenever I go from Bangalore to Udupi to Bangalore in my car, when I park my car, when I lock my car, I get a message in my mobile. If I open that message, it gives me the entire analysis of my driving. What is the distance the car has traveled? What is the fuel efficiency? So, what is the driving rate? Are you harsh in driving? Are you harsh in turning your steering? Are you harsh in accelerating? Are you harsh in pressing the brake? Entire around 8 to 10 different parameters are analyzed, wherein I can see my performance with the car. So I've given an example of the car. So it could be with any IoT devices. An application software could control the devices. Application software could monitor the system status. At the same time, application software could view or analyze the processed data. So applications make the IoT system usable and meaningful for end users. That's the main purpose of the application. Purpose of application is to get the meaningful and get the useful information to the end users. Okay, so that they can later depend upon the IoT system to improvise their activities. So these are the application software. So there's a diagram where you can see a device which consists of IoT based sensors and the intermediate devices. So all the physical devices which are connected, which makes use of communication channels, and we have got management activities. So management activities and security also, which are provided by the system which take care of the services as well as communication. Ultimately an application program is associated with these devices, so the user is connected to these devices by means of the application. So application model is at the higher end, below which you have management activity to manage the activities, security to provide the various security system as we discussed. So we have different activities like services and communication channel for communication, for getting communication. So ultimately this is the diagrammatic representation of what we have discussed so far. Now let's look into the IoT communication models. We all know that IoT devices need communication with the device to device or device to application, vice versa. So, when IoT has a communication system, IoT uses various communication models. One of the fundamental communication models which IoT uses is a request response model. It is a simplest model, synchronous pattern similar to how the website is working. So we know how the website is working. It's a request response model. What do we mean by request response model of the websites? I'll take an example to prove my concepts. Say I'll open a browser. So when I open a browser, in the browser, I will type the URL. Let us say I type say Srinivas University dot edu dot in. So this is my request sent from the client. My request goes to the server and server is responding to my request and it is sending the home page to my system and I will be displaying the home page in my client. So here the client is requesting and server is responding. It's a basic concept of how do we go ahead with the request response pedagogy. So most of the clients, normally it's a simplest method which we observe, which we do in the communication, wherein we have a request from the client and response will be given from the server. So this is how we go ahead with the concept of request response concept. So it's a model which is considered to be a fundamental model where one of the IoT device, normally we call it a client, sends the request to another device. It also could be a IoT device or it could be a server or it could be any application. Normally it's a server or it's a device. So the device is then giving a response. The IoT device is it's a client which sends a request. If I take an example of, let's say, irrigation system, the sensor, the humidity sensor is a IoT device, acts like a client, sends the request to the app, to the mobile app, stating that yes, mobile app is basically it's a app which is connected to the server. So the sensor is sending the data or request to the server, stating that yes, there is a need to irrigate. Let us switch on the irrigate. Please send a command to switch on the irrigate. So this is a request sent from the IoT device and this device is considered to be a client. So here the communication is initiated by the client and for every initiation of the client, the server is responding with the data or with the action result. In the case of irrigation system, it sends a data to the server. Server notifies that yes, there is a need of water. So it takes an action result. What is an action result? Server sends a action to switch on the pump so that irrigation system can automatically start. So normally it could be a data display from the server like I would like to see what is there going, what are the things going on nearby my home using CCTV camera. So all my CCTV cameras are IoT devices, like a client devices, and they are all initiating a request to the server. I open the server using my mobile so that I can see what's all going on. So it's a data which is represented. So server is responding the relevant data, and then an action is taken for a necessary activities. So this is how the request response concept works. The thing is, how does the request response work? The first activity is client, which is an IoT device, sends a request. The request could be in the form of a data, the request could be in the form of a command, the request could be in the form of queries. So data, relevant data. Suppose if I would like to see what is going on surroundings my home, the request is actually the CCTV camera data. So CCTV camera data is given and I am able to connect it to my server and I can get the CCTV footages, dynamic or live videos I can see. Then coming to commands. So I get a statement, I get a client IoT from my car stating that suppose if my driver is taking my car, so if I am getting a message from the car's IoT system that the door is not properly locked, so I can send a command to switch off the engine of the car. So suppose if somebody is stealing my car and my IoT system, my client system is responding, it is sending a request data to my server, and I could send a command to stop the car. So client can also send a command. In the case of irrigation system, client is sending a command to switch on the motor, switch on the pump, or you can send even the queries also, like when my car is going, what is the conditions of my car, how, what, at what speed my car is going, what are the parameters, various parameters of my car, whether are they are all okay or not, car is going at what speed, in which direction it is going, where it is going, GPS location, etc., etc. All the queries will be given from the respective IoT devices. All these devices are client devices. Then next activity is server is receiving the request. Server receives the request. Okay. Now the server could be in different form. I can have a dedicated server wherein it uses possible communication protocols and it uses a class A addressing scheme to locate my server, and it communicates, the client communicates the data to my server. A server is accepting the data through communication lines. But nowadays, most of the people don't use the dedicated server because we have a lot of space available in the cloud platform. So most of the time, all these servers are placed in cloud platform so that I can share the cloud platform. So with the different services, and the servers, different servers may be updated in the cloud platform. So servers can also be in the cloud platform. I can have a dedicated server also, or I can use a local gateway. Local gateway means if I use an irrigation system, I need not connect it to my remote application. The sensor can be directly connected to local gateway. Through local gateway, it is connected to the pump. Pump and IoT devices are communicating locally. It doesn't require any external communication devices or another IoT device, as I already mentioned. The services can be provided. Servers can be thought in connection with IoT as a cloud platform, dedicated server, local gateway, or another IoT devices. Now, next activity is server is processing the request. Depending upon the nature of the client request, server is processing the request, then server is sending the response back to the client. So, server is processing the request. Suppose if I say car is being getting stolen, so I will be the client, the IoT device in my car is a client which is sending the data to the server. Now server is processing the data and it says that yes, you switch off the engine of the car, so that is a response sent back to the car. So these are the activities which the IoT system is working. Client IoT device is sending a request, server is receiving the request, server is performing the process, then server is sending the response back to the client accordingly. So here we use the different protocols, higher level protocol, network level protocol, and even interface level protocols. We use a family of TCP IP. So basically, we use HTTP or HTTPS. It's a common cloud communication. Basically, higher end protocols. Then CoAP, constrained application protocol, for lightweight for constrained IoT devices. So this is a protocol dedicated for IoT devices. MQTT, request reply platform. So same cases, MQTT is also a protocol which is working for the IoT devices, for the light constrained devices. So let me say, for example, a smart agriculture moisture sensor sends an HTTP request to the cloud server. What is it? Send me the latest irrigation schedule. What is the response from the client server? Server says that okay. The cloud server replies like irrigate for 10 minutes. So request is sent from the IoT device. What is the latest irrigation schedule? So that server is processing the data by taking various parameters. Then finally, the server is sending a response, irrigate for 10 minutes. So that automatically irrigation takes place for the 10 minutes. Then the sensor acts based on the response. It's a very simple example. How a client is sending the request, how the request is sent to the server, how the server is processing the data, how the server is then responding, then how the finally the sensor acts based on the response. Okay, so this is a diagrammatic representation of how a client is placing a request to the server. So client is always using HTTP and HTTPS protocols, and even lower layer protocols also. It uses all sorts of protocols. Certain protocols which are, as we discussed, dedicated to the IoT system, and then all the IPv family is being used for communication to send the data from client to the server. So server receives the data from the client, processes the request, then looks up from the resources, fetches the resources, prepares the response, and sends the response back to the client. This is a diagrammatic representation of request and responses pedagogy of the IoT communication system. Client is placing a simple request. The server plays a very important role here. It is receiving the request, it is processing the data. For processing the data, it requires a lot of resources. And using those resources, it does the processing work. Then it prepares the final response, and this response goes back to the client for the activity. So this is a simple concept of client server response or a technology. The next model is the publish subscribe model. This is one of the most important communication models used in IoT systems. It allows devices to communicate indirectly through a broker. So in the previous case, what we saw is it's a direct communication wherein a client is directly sending the data to the server. Server is accepting the response, then it is processing, then it is sending the result back. But in this case, the IoT devices are communicating indirectly with the help of a broker other than directly communicating with each other. Let's see what is the meaning of this. So here, publishers send the data to a broker. Subscribers receive data from the broker by subscribing to specific topics. Publishers and subscribers do not know each other. See, this improves the authenticity. So, direct submission and direct result is not there. There are intermediate devices called broker as well as subscribers. Subscribers are receiving the data from the brokers, and publishers are sending the data to the broker. and the publishers and subscribers, they don't know each other. So here a concept of authenticity is improved, or it is more, wherein publishers as well as subscribers are not directly in contact, because there are broker who are in between publisher as well as the subscribers, which share the data. So this is a definition where the publisher is sending the data to the broker, broker is then forwarding the data to the subscribers, and then subscribers will send the result back in the same way. So the concept is publishers and subscribers should not know each other. So as I already mentioned, temperature sensor publishes to topic called home slash room one slash temp, means temperature sensor keeps on adding the data under that particular folder called home.room1.temp. See, the concept of request response is the temperature sensor is dynamically sending the temperature to the through the communication medium to the server. But in this case, it's not so. The temperature sensor is publishing its updated temperature information in one file called temp located in one particular directory. Now, broker will receive this data from home slash room one slash temp and publishes all the messages using MQTT broker. Now, subscriber subscribes the topic of interest, like it device, the display device subscribes to same folder. Broker delivers a message to all the subscribers of the topic. So here subscribers and brokers are making use of updated information in temperature within particular folder, and this data is getting updated, and the publisher is not directly publishing it, it is sending the data in this particular folder. Brokers and the subscribers are getting the data through that folder and through that file, and they communicate it, they use it. So normally we use message queuing telemetry transport, MQTT protocol for the above purpose, where we have broker and subscriber concept, and we use AMQP DDS, data distribution services, also are the common protocols which we use for publish and subscribe based method of communication. So another example is given, a greenhouse setup. Always it temperature sensor publishes the data under one particular folder. Now mobile application is subscribed to the same topic, the same folder. And then it the broker MQTT forwards the temperature updates to the application in real time. Normally, this concept is working something like this. So, we have, in case of artificial intelligence or in case of machine learning and all, we require certain data sets. We require some CSV files, or we require some file having a huge number of data. And using those huge number of data, we can predict. See, for example, weather prediction. Tomorrow it is going to be raining or not. What is the temperature expected tomorrow? So to do all these things, your real-time temperature is not the only one which is required. We require past history. So when we require data, huge amount of data of past history, like humidity data, air pressure data, temperature data, flow of air data. See, these are all the various data required for another 15 days or past 15 days or 1 month. So your request response model does not work here. So here the model which is working, publish and subscribe, wherein IoT system keeps on updating the table. Sensor table, temperature sensor table keeps on updating the temperature information. Humidity sensor table keeps on updating the humidity details. Pressure air pressure. So like this, various IoT devices go on updating their respective tables, and then these respective tables will be used by the applications to get the updates in the real-time applications. So because of which we are able to get tomorrow is a training. What is the expected rain tomorrow? What time it is going to be raining and what time it is going to be sunny day, or what is the temperature expected tomorrow. So these are all the predictions what we get. We get the predictions using the past data. And who is going to give the past data? These IoT devices which are going to give the past data, and then these data are used in the form of publish and subscribe model. So this is an explanation for the publish and the subscribe model, where publisher sends the message of the topic. These messages are getting stored in the subscribers, broker. So here the consumers require certain data from the broker. Here consumer 3 may require another data from the broker. So these data, whatever are needed, see, it might not be every data. So whatever data which are required to different consumers will be used in this from the broker. A publisher keeps on updating the real-time data, but the real-time data will not be used by the consumer. Instead of using real-time data, it takes the past data also through the brokers. So this is what is a concept of publish and broker method of model. Then next one is what is called push pull model, where producers are considered to be publishers. They push the data into the queue. Consumers are considered to be subscribers. They get the data in the same queue whenever they are in need of it. So push pull model, which works exactly like the previous data. So here there are key points to be noted for the push pull model is: producers push the data to the data queue. They need not know who the consumers are. See, the data is one more point I forgot to tell here. See, whatever data the broker is going to get, it doesn't know who are the customers, consumers who are going to take the data. It keeps the data ready. So whoever comes, whoever consumer come, he can use the data and he can process the data. So like this, in the same case, push pull model also doesn't know who are going to use the data, but it just updates the queue. Consumers will pull the data of their requirement, then they decouple, the queue decouples producers and consumers. Producers and consumers do not have to operate at the same speed, at the same time, same speed. Then it acts as a buffer. The queue is acting like a buffer for the mismatch speed. Some devices are faster, some devices produce data faster, some devices produce data at a slower rate. So here the buffer is acting like a buffer. The queue is acting like a buffer to match the flow of data from the fast data flow to the slower data flow. Then reliable communication. So it ensures a smooth data flow in the system. So that is a push pull. So same way, see, the diagram is very clear. There is a queue. See, in this case you have only a broker, but in this case same model, where publisher is keeping the data in the queue, consumers are taking the data from the queue, so and they process the data. The only difference is, in the previous case they can take whatever data which are required. There is a possibility of selection of data, but in this case queue means they have to get whatever available here. They cannot take by bypassing this data they cannot take. So this is what is called a push pull model. Then exclusive pair model. It's another communication model which is bidirectional, fully duplex, a persistent one-to-one connection established between a client and a server. So the connection is kept open for continuous communication until it is explicitly closed. As I already mentioned, a smart home security camera is persistently keeps a TCP connection until you are monitoring it. So the server keeps a connection, and then using that connection, the monitoring activity takes place. Camera can stream the data, camera can send the data without reconnecting. So exclusively, this is what is called exclusive pair model. So here you have client as well as you have server. Basically, this particular concept works with a TCP based model wherein a request to connect is sent to the server. Server will respond by accepting the connection. Connection is established, then messaging will go from the client to the server, and every message is sent back as a response from the server to the client. Then once everything is completed, it closes the connection from the client's side, and it closes the connection from the server's side. This is exactly working something like three-way handshake signal method and modified three-way handshake signal. First connection is established by sending a request. It accepts a request. Message will go from the server. Response will come from the server. This keeps on going. Messages keep on going, and for every message, server is sending response. And once the connection is closed, request will be sent from the client to close the connection, and every request is accepted by the server to close the connection. So, this is what is the different communication model. So, thank you for watching.